Assalamualaikum warahmatullahi wabarakatuh. Let me introduce myself. My name is Bunga Aprilia. I'm from Department of Physics, Universitas Andalas. Okay, here I will explain about my research entitled Classification of Precipitation Types from Micro and Radar Observation using Artificial Neural Network. This is my outline presentation is introduction, methodology, result and discussion, and then conclusions and suggestion. Rain is divided into two main classes, namely stratiform and convective. The rain classification is useful for evaluating climate models. Stratiform and convective rains have different physical characteristics. Therefore, certain methods are needed to classify these rains. From a brief history of the development of these methods, the right method for classifying rain has not been found. Therefore, I conducted research related to classifying rain using vertical radar data and the ARN method. The hope from the output of this research is to obtain a simple and accurate method for classifying rain using vertical radar data and the artificial neural network method. The last research on rain classifying was conducted by Wang et al. In 2017 and Ramadan in 2020. Both of these studies only used the breakband method, and the disadvantages of this research are not all rain data is classified. That is, it only classes stratiform rain. The next research was filed in 2020, and at this time I am conducted research related to the classifying of the rain data. The way that I do in this research to improve the accuracy of classifying and the difference between my research and previous research that is what are I uses ARN model backpropagation. Optimization is variation of learning rate, and then rain type is stratiform, mixed, deep convective, shallow convective, and no type. My MRR or micro radar is radar or radio detecting and ranging which transmits signal using a frequency modulated continuous wave. Advantages of micro radar is high sensitivity and finer temporal resolution so that it can detect very small amounts of precipitation. The accuracy of the artificial neural network method will be better if the training data used is more than the test data. Therefore, the first step I took in this research was to filter the rain data to obtain long-duration rain data that will be used as training data and test data. The rain event on January 5 in 2017, our third period, had the longest duration of 294 minutes. Therefore, the rain event in the third period on January 5, 2017 was used as training data. The testing process of ARN backpropagation was carried out using several other rain data like table 1. The result of the training and testing of the ARN backpropagation method were then validated with the result of the modified version of Williams et al.'s or breakband BB method. This is the table 2, the result of the rain classifying learning rate variation training using ARN backpropagation competitive function rain on January 5 in 2017 for third period. More accurate training results are or smallest training MSE value in the rain classifying process are a competitive function with a learning rate value of 0.9, like table 2. The MSE value of the training was 0.009875, which stopped at the 11th epoch. This is the table 3. The result of the rain event test using ARN backpropagation competitive function and learning rate of 0.9. The average percentage of the ARN method classifying accuracy from the above test is 94%. This value indicates that the two methods have strong relationship between variables. Based on this, it can be stated that the ARN backpropagation method of competitive function and learning rate of 0.9 is a simple method that is accurate and precise for classifying rain from micro and radar data. This figure is validation of ARN and BB. Stratiform rain from the rain event on December 5 in 2016, December 14 in 2016, January 5 in 2017 for the third period, and February 21 in 2017. The melting layer, or ML, which is the main indicator of the formation of stratiform rain, was observed during this period with an altitude of about 4,500 meters, like Figure 1A, Figure 1B, Figure 1F, and Figure 1G. The convective from the rain events on January 5 in 17 for the first and second periods, like Figure 1C and 1D. The reflectivity counter of the radar shows that in these two rain events there is no melting layer, which is a requirement for deep convective rain, like Figure 1C and 1D. Mix from the rain events on January 14 in 2017. In Figure 1F, it is shown that melting layer was observed, and this is a supporting factor in the process of forming mixed rain. The conclusion is based on the reflectivity radar counter, which indicates the presence or absence of the melting layer, then the classifying of rain by ARN backpropagation, which only produces one type of rain, is more acceptable than the breakband method. Okay, the conclusion of my research is the result of the study showed that ARN backpropagation can classify the type of rain from micro and radar observation. The most appropriate ARN backpropagation architecture is the 3-6-1 architecture, with an activation transfer function that is competitive and a learning rate of 0.9. The training MSE value of this architecture is 0.009875, and the average percent of classifying accuracy for testing on 6 rain events is 94%. The ARN method can classify rain very well for rain that tends to be uniform. This can cover the shortcoming of the BB method, which often groups several minutes of data between the dominant rain type into other type of rain, which is physically impossible. And thank you. Assalamualaikum warahmatullahi wabarakatuh.